Welcome to Cosmic Wonders podcast series. Today we're embarking on an incredible deep dive into the very fabric of everything around us and everything beyond. We're going to explore what the universe is truly made of, and trust me, it's not just stars and planets. It's far more mysterious and exciting.
That's right. Imagine trying to understand a giant puzzle, but most of the pieces are invisible.
Okay.
That's a bit like what scientists face when they look at the universe. We'll break down these cosmic building blocks into three main components.
Right.
And you might be surprised to learn how little of the universe is actually the stuff we can see.
Oh. Okay, let's unpack this. Our mission today is to peek behind the curtain of the cosmos and discover what's really holding it all together and maybe what's pushing it apart. Get ready for some mind-bending facts.
Let's start with a big idea.
Yeah?
Matter. Matter is, well, anything that has mass, meaning it has weight and takes up space.
Sure, like this microphone, the chair I'm sitting on.
Exactly. Like a book, a backpack, or even the air you breathe. We can observe all of these things, right?
We can. But here's where it gets really interesting. If we think of the entire universe as, say, a giant pie,
Yeah.
only a tiny, tiny slice of it is made of the matter we can actually see or touch.
Exactly. Current understanding suggests the universe is composed of three main things, and two of them are completely invisible to us.
2 out of 3. Wow.
Yeah. First, what we call normal matter. That makes up a surprisingly small 5% of the universe.
Just 5%.
Just 5. Then there's dark matter, accounting for about 27%.
Okay, bigger chunk.
Much bigger. And finally, the most abundant and mysterious of all, dark energy. That makes up a whopping 68% of everything.
68%. So what does this all mean? It means most of the universe is a complete mystery to our eyes.
That's the crux of it.
Let's dive into that tiny 5% first, normal matter. This is the stuff we're familiar with, everything you can directly observe.
Right.
Your friends, the Earth, the sun, distant galaxies, it's all normal matter.
We can see it with our own eyes or with telescopes that detect different kinds of light, like ultraviolet or infrared light.
Ah, the ones that see things our eyes can't.
Exactly. They're like special kinds of invisible light that can reveal more detail about this normal matter.
And it's made up of tiny little building blocks called atomic particles, like protons, neutrons, and electrons.
That's the stuff. Think of them like the individual Lego bricks that make up everything.
Okay.
And normal matter can exist in different forms, as a gas, a solid, a liquid, or even a super hot plasma of charged particles, like you find inside a star.
Got it. The familiar 5%. Now let's talk about dark matter, the 27% slice.
Right. Now, dark matter. Just like normal matter, it takes up space and has mass, it has weight.
Okay.
But here's the kicker. It doesn't reflect, absorb, or give off any light. It's completely invisible to us.
Completely. So telescopes are no help?
Nope. None at all. It's like a silent, invisible guardian, making up, as you said, 27% of the cosmos.
Scientists aren't sure exactly what it is, right?
Not exactly. They think it might be made of special, tiny particles that hardly ever interact with normal matter. Very elusive.
So how do we even figure out it exists if we can't see it?
Well, what's fascinating here is how we realized it existed. Back in the 1930s, there was an astronomer named Fritz Zwicky.
Blicky, okay.
He was studying this huge group of over 1,000 galaxies called the Coma Galaxy Cluster. And he noticed that these galaxies were moving much faster than they should have been based on how much visible matter was there.
Faster. Like,
Yeah.
too fast to stay together.
Precisely. Think about a merry-go-round. If it spins too fast, you might fly off.
Right.
Zwicky thought something invisible must be adding extra weight or, gravity to hold these fast-moving galaxies together.
So missing gravity, basically.
Missing gravity, yeah. Then, in the 1970s, another amazing astronomer, Vera Rubin, she confirmed this idea.
How did she do that?
She studied how individual galaxies rotated, specifically spiral galaxies. She found that the outer parts of galaxies were spinning just as fast as the inner parts.
That sounds weird. Shouldn't they slow down further out, like planets orbiting the sun?
You'd think so. Usually things slow down as you get further from the center where most of the visible mass is concentrated. Her observations showed there had to be a huge invisible halo of mass surrounding these galaxies.
A halo.
Yeah, an invisible halo creating extra gravity to keep them spinning so quickly. Without it, the outer stars should just drift away.
Wow. So Zwicky saw it in clusters, Rubin saw it in individual galaxies.
Compelling evidence from different scales.
So what does this all mean? Scientists now believe dark matter forms a vast, invisible, web-like structure throughout the universe.
That's the picture, yeah. You can imagine it like a giant cosmic spider web or maybe an invisible scaffold.
A scaffold.
Yeah, one that pulls normal matter towards it gravitationally, helping to form galaxies and clusters of galaxies where the dark matter is densest. It's the universe's unseen gravitational glue.
Okay, invisible glue holding things together. Makes sense for 27%. But now, the biggest slice. Dark energy, 68%.
Right. If dark matter is mysterious, dark energy is even more so. It makes up the largest part of the universe, about 68%, and we know the least about it.
But we know it must exist. How?
Something like dark energy must exist to explain something incredible we've observed about the universe's expansion.
Okay, I know the universe is expanding. That's been known for a while, right? Since Hubble.
Exactly. For a long time, since the late 1920s, astronomers knew that the universe was getting bigger, expanding, like a balloon being slowly inflated.
Right, everything moving away from everything else.
But then, in the 1990s, scientists made a truly surprising discovery by looking at distant star explosions called supernovae. Type Ia supernovae, specifically.
The standard candles. They use those to measure cosmic distances.
Precisely. They're reliably bright. And by looking at these very distant ones, they realized something astonishing.
What was that?
The universe wasn't just expanding. It was expanding faster now than it did in the past. The expansion is accelerating.
Accelerating? Wait, shouldn't gravity be slowing it down? Pulling everything back together?
That's what everyone thought. Imagine blowing up a balloon, but then suddenly it starts inflating at super speed, all by itself. It's counterintuitive.
Totally. So, what could be making the universe speed up its expansion? That sounds like anti-gravity.
Sort of. The leading idea is dark energy. It's thought to be something that has a kind of repulsive gravitational effect. Instead of pulling things together like regular gravity or dark matter,
It pushes.
it actually pushes the universe apart. It acts like a pressure filling space. It's the ultimate cosmic accelerator.
Whoa. So dark matter pulls things together, forming structures, and dark energy pushes everything apart, accelerating the expansion.
That's the current picture. A cosmic tug of war, but dark energy is winning on the largest scales.
So what does this all mean for you listening? Well, it means that despite all our amazing telescopes and smart scientists, most of the universe remains a profound mystery. We're still figuring out what the vast majority of everything is made of. 95% is dark.
It really highlights how much there is still to learn and discover. The universe is like this giant, unsolved puzzle.
Yeah?
And every new piece of information we find, even about the invisible parts, helps us understand our place in it a little better.
So as you look up at the night sky, remember that behind every twinkling star and visible galaxy, there's this incredible, unseen framework.
Yeah, think about that.
This dark matter holding things together and this dark energy pushing everything further and further apart. It's a truly mind-blowing thought, isn't it?
It really is. And who knows, perhaps the next generation of scientists, maybe even some of you listening, will be the ones to finally unravel these cosmic secrets.
Finding out what dark matter and dark energy truly are, that would be huge.
Absolutely. It could change everything we think we know about physics. There's so much still out there.
Thank you for listening to this Cosmic Wonders episode.